Let's take a look today at the second part of factoring. If you remember from last class, we learned how to factor some very quick and easy problems that required your multiplication rules. Then we also learned about dots, and we also learned about the GCF. But the one thing that was consistently the same about every single one of those problems was x squared didn't have a number to deal with. Today, we are learning another method for factoring called the British method. This method is used when we have a number in front of x squared that won't go away. Okay, no GCF can get rid of this number now. So what we're going to do is, these are some written instructions. Instead of just reading them all to you and getting you completely confused, we're going to do one line at a time with an example. The most important thing that you need to know is that A is always first, B is always in the middle, and C is always at the end. So let's take a look at our first example. 3x squared minus 10x plus 8. If it's helpful, you can put a little A, B, and C above those three numbers. Our first step of this British method process is to multiply the A number and the C number together. Well, A is 3. Notice I didn't include the x. C is 8. 3 times 8 is 24. Now that number is really important to us, but it's not going to go in the equation. We're going to jot it down over here off to the side. That's step number 1. Pretty easy. Let's look at step number 2. We're trying to find two numbers that multiply, does that sound familiar? To give you, here's the difference. Our multiplying number is A times C, the thing that we just found. And add to give you B. So let me show you where we're at. Our new multiplying number is this guy. That's the big change from the last day. We are now multiplying to try and get 24. We are still adding to get negative 10. So let's write out our options just like we did last time. 24 is 1 and 24. 24 divided by 2 is 12. 24 divided by 3 is 8. And 24 divided by 4 is 6. That's our list. Now we need to address our signs. We are multiplying to get a positive, but adding to get a negative. When we multiply to get a positive, we have two positives or two negatives. Because this guy is negative, all of these numbers are negatives. So what is the pair that multiplies to give you 24 and adds to give you negative 10? If you look through these pairs and you add them up, the only one that works is that pair right there. Now this is where we get different. You're not putting those in parentheses. We got to look back at our instructions. Step number 3, we're going to replace the B term. Okay, the B term is going away, and it's going to be replaced with the two numbers we just found. So let me show you what that looks like. This guy is going bye-bye. These two numbers are replacing him. So the 3x squared is not going anywhere. And the 8 is not going anywhere. The negative 10x is gone. The two numbers we just found are replacing it, but because we're taking out an x, they both have x's. It is now minus 4x and minus 6x. What we did was we took the middle part and we split it apart. We haven't changed the problem, we just split it up. Let's go back to our instructions. We're now going to factor out the GCF, that's familiar, of the first two terms and factor out the GCF of the last two terms. In other words, we're splitting our problem in half. And I'm literally going to do that. I'm going to take my pencil and I'm going to draw a line down the middle. GCF is what do they have in common? So first question, what can 3 and 4 both be divided by? The only answer is 1. However, they have more stuff in common. This guy has an x and this guy has an x. Specifically, this one has 2 x's, but this one only has 1 x. So what they both have in common is an x. So I'm going to write an x down as well. That is your GCF. Now we have to divide by that GCF to see what's left in the parentheses. 3 divided by 1 is 3. 2 x's, take away 1x, leaves me with 1x. Negative 4 divided by 1 is negative 4. 1x, take away 1x, leaves me with no x's. 1 take away 1 is 0. We're going to do the exact same thing on this side. What can 6 and 8 both be divided by? Well, that's 2. Here's what's important though. Whatever sign you see here comes down. Do both of these terms have x's? No. There's no x in common on that side, so we don't write it. Negative 6 divided by negative 2 is positive 3. The x stays with the 3. And 8 divided by negative 2 is negative 4. Watch those positives and negatives. Now, I didn't read all of step number 4. I want to go back. There's a little note here. It's really important. What remains in both sets of parentheses should be the same. If your parentheses don't match, you did something wrong. Look at my parentheses. 3x minus 4 and 3x minus 4. They match. That's how we know we're doing it right. Final step, put the common stuff that matched in one set of parentheses and what remains in another set of parentheses. This is finally where we get to do our two parentheses. The first set is this matching stuff, 3x minus 4. The second set is the stuff on the outsides, the 1x minus 2. And we are done with that problem. So let's take a look at another one together. So we're going to try not to switch back and forth to the rules. First thing we did on this problem, we labeled A, B, and C. Well, what's B? Because B can't be x. B is an imaginary 1. We multiplied A and C to get 24. So 6 times negative 15 is negative 90. After we multiplied, we labeled. We are looking for two numbers that multiply to give us negative 90 and add to give us a positive 1. Let's make our list. We know we got 1 and 90. 90 divided by 2 is 45. 90 divided by 3 is 30. 90 can't be divided by 4. 90 divided by 5 is 18. 90 divided by 6 is 15. 90 can't be divided by 7. And 90 can't be divided by 8. And 90 divided by 9 is 10. We are looking for two numbers, though, that multiply to give us a negative. That means one is positive and one is negative, but they have to add to give us a positive. That means the bigger number is positive. So my small list gets the negatives. So what is my pair that multiplies to give me a negative 90 and adds to give me a positive 1? Well, the only pair in this group that works is right there. What do we do with those numbers now? We don't go to parentheses. This is when we took our middle guy and changed him. So we're going to take our middle guy and change him. 6x squared stays, negative 15 stays. The middle is now minus 9x, because that tags along, and plus, must have the plus sign, plus 10x. What did we do after we put the two ones in the middle? We drew our line down the middle. Draw my line down the middle. We are looking for stuff in common. 6 and 9 can both be divided by 3, and they both have an x. Let's divide and see what's left. 6 divided by 3 is 2. 2 x's, take away 1, leaves us with 1. Negative 9 divided by 3 is negative 3. 1x, take away 1x, leaves me with no x's. On the other side, 10 and 15 can both be divided by 5. Bring down that sign in front. There are no x's in common here. I'm going to divide by 5. 10 divided by 5 is 2. The x stays there. Negative 15 divided by 5 is negative 3. Pause, check your parentheses. 2x minus 3, 2x minus 3, they match, that's good. Final step is our two parentheses. The matching stuff goes in the first one, 2x minus 3. The non are the outside stuff, the 3x and the plus 5 goes in the second set. And that problem is done. This is a process that once you get the process, some students like this better than yesterday's lesson. So turn to example 2, pause the video, try both of these on your own. Okay, let's see how you did. So we have A, B, and C. We multiply A and C, and we get 210. Yes, big number. We are looking for two numbers that multiply to give us 210 and add to give us negative 31. Start your list. 1 and 210. 210 divided by 2 is 105. 210 divided by 3 is 70. 210 can't be divided by 4. 210 divided by 5 is 42. 210 divided by 6 is 35. 210 divided by 7 is 30. 210 can't be divided by 8 or 9. But 210 divided by 10 is 21. Positive here means there are two positives or two negatives. A negative here means all negatives down the lists. Which pair worked? The bottom pair. Come over here. That guy changes. 6x squared minus 10x minus 21x plus 35. Split it down the middle. On this side, 6 and 10 can both be divided by 2, and they both have an x in common. 6 divided by 2 is 3. X is left over. Negative 10 divided by 2 is negative 5. No x is left over. 21 and 35 can both be divided by 7. Bring down the negative. Negative 21 divided by negative 7 is positive 3x. Positive 35 divided by negative 7 is negative 5. Watch your signs. These match. Our inside matching stuff is 3x minus 5. Our outside leftover stuff is 2x minus 7. Insides, outsides, that is a done problem. Let's see how you did on this one. A, B, and C. We are multiplying A and C to get 15. We are looking for two numbers that multiply to give us 15 and add to give us negative 16. 15 has a short list. It's 1 and 15 or 3 and 5. The multiplying number is positive. That means there are two positives or two negatives. The adding number is negative. That means there are two negatives. The only pair that multiplies to give, or that adds to give you negative 16 is the top pair. Come over here and replace that guy. 3x squared minus 1x minus 15x. Keep the plus 5. We are ready to split it down the middle. 3 and 1 can only be divided by 1. They have an x in common. 3 divided by 1 is 3. There's an x left over. Negative 1 divided by 1 is negative 1. No x left over. On this side, 15 and 5 can both be divided by 5. Bring down the negative. Negative 15 divided by negative 5 is 3x. Positive 5 divided by negative 5 is negative 1. Do the parentheses match? Yes, they do. Insides, 3x minus 1. Outsides, 1x minus 5. So once you get the hang of it, these won't be too bad. Let's add one little step to the front of these. We are still factoring, but notice the directions say you might need to use a GCF first. The bigger the numbers, the harder it gets. So let's take a look and see if there's something that we can use to make these numbers smaller. 8, 28, and 120. What can they all be divided by? Well, they can't all be divided by 8. However, they can be divided by 4. So I'm going to write down my 4 and divide every single one of these by 4. 8 divided by 4 is 2x squared. 28 divided by 4 is plus 7x. Negative 120 divided by 4 is negative 30. Wouldn't you rather work with numbers like 2, 7, and negative 30 rather than 8, 28, and 120? Makes the numbers a lot smaller. Now, just like before, I'm going to put my little box over my 4. He's not there right now. I'm going to label my A, B, and C. And my first step is multiply A and C to get negative 60. I am looking for two numbers that multiply to give you negative 60 and add to give you 7. Let's start our list. We always got 1 and 60. 60 divided by 2 is 30. 60 divided by 3 is 20. 60 divided by 4 is 15. 60 divided by 5 is 12. And 60 divided by 6 is 10. We are looking for a negative multiplier. That means we have one positive, one negative, and the bigger number is positive. So I'm going to put negatives with all these short guys. Which pair adds up to 7? That will be that pair right there. So we're going to ignore the 4 still. We're going to replace that guy. 2x squared minus 5x plus 12x minus 30. Split it down the middle. What can 2 and 5 both be divided by? Only one, but they both have an x. 2 divided by 1 is 2. There's 1x left over. Negative 5 divided by 1 is negative 5. There are no x's left over. What can 12 and 30 both be divided by? Well, that's 6. Bring down my plus sign. 12 divided by 6 is 2. X tags along. Negative 30 divided by 6 is negative 5. Do our parentheses match? Absolutely. We are ready for insides, which are 2x minus 5, and outsides, which are 1x plus 6. However, the highlighted box needs to come down in front. That's the only difference between the first two sets of examples and these, is that you have to do a GCF first. So let's look at 3b together, and then you have 2 to try on your own. What can negative 25, 60, and negative 35 all be divided by? Well, they're all divisible by 5, but we're going to make it, because this is negative, we're going to make it a negative 5. However, there's something else different here. Look at this 3, this 2, and this x. Every single term has an x, and we've never seen x to the third. That means that you need to put an x here as well. Let's see what's left over. Negative 25 divided by negative 5 is positive 5. 3, take away 1, leaves me with 2. Positive 60 divided by negative 5 is negative 12. 2, take away 1, leaves me with 1. Negative 35 divided by negative 5 is positive 7. 1x, take away 1x, leaves me with no x's. We are ready to do this problem. We need to label A, B, and C. Whoa, where did I get 7 from? I apologize, guys. I'm changing up my problem. No, I'm not. We're good. And we are looking for two numbers. We need to multiply A and C together. Now, I'm out of space, so I'm going to squeeze it up here. A times C is 35. So I am looking for two numbers that multiply to give me 35 and add to give me negative 12. Sorry guys, I'm out of space. Let's make our list. It's a short list. 35 only has 1 and 35. Or the only other pair is 5 and 7. Well, I have to multiply to get a positive, so that means I have two positives or two negatives, and I need to add to get a negative. That means I have two negatives. Which pair gives me negative 12? That's that pair right there. So let's write it down. He's changing, keep the 5x squared, change it to negative 5x, and negative 7x, keep the 7. Don't forget, guys, we're ignoring this guy for a moment. We'll come back to it. Draw your line down the middle. 5 and 5 can both be divided by 5. There's an x in common. 5 divided by 5 is 1. X tags along. Negative 5 divided by 5 is negative 1. Over here, 7 and 7 can both be divided by 7. I gotta bring that negative down. Negative 7 divided by negative 7 is positive 1, x. And positive 7 divided by negative 7 is negative 1. Do my parentheses match? Absolutely. I'm ready to do insides and outsides. 1x minus 1 is on the inside. 5x minus 7 is on the outside. Also on the outside is my negative 5x. Right, so pause the video, try both parts of example 4 on your own, and when you're ready to check, go ahead and unpause it. So let's see how you did. First of all, the greatest common factor was 3. You should have divided and gotten 2x squared plus 1x minus 3. A, B, and C. Multiply A and C, and we get negative 6. We are looking for two numbers that multiply to give us negative 6 and add to give us 1. Only options, 1 and 6, 2 and 3. We need to multiply to get a negative, 1 positive, 1 negative, add to get a positive. The bigger one's positive. Which pair adds up to get us a 1? That would be this pair. We are ignoring our 3 here. All right, so let's see what we have. We have 2x squared plus 2x. Sorry, we talked about negatives. Sorry, minus 2x plus 3x minus 3. Split it down the middle. 2 and 2 can both be divided by 2. X and x have an x in common. 2 divided by 2 is 1x. Negative 2 divided by 2 is negative 1. 3 and 3 can both be divided by 3. Bring down the positive. 3 divided by 3 is 1x. Negative 3 divided by 3 is negative 1. Insides match. 1x minus 1 are your insides. 2x plus 3 are your outsides. Bring down your 3. And let's see how you did on B. 12, 34, and 24 are all divisible by 2, but they also each had an x in common. 12 divided by 2, 6. We're left with x squared. Negative 34 divided by 2, negative 17. We're left with x. 24 divided by 2, 12. No more x's. Hiding that guy temporarily. Label A, B, and C. Multiply A and C, and we get 72. We are looking for two numbers that multiply to give us 72 and add to give us negative 7. Longer list. 1 and 72. 72 divided by 2 is 36. 72 divided by 3 is 24. 72 divided by 4 is 18. 72 divided by 5 doesn't work. Divided by 6 is 12. 72 divided by 7 doesn't work. 72 divided by 8 is 9. We need to multiply to get a positive. 2 positives, 2 negatives. But we need to add to get a negative 17. That means all negatives. The only pair that adds up to give us a negative 17 is that pair right there. We are going to split him up, keep 6x squared, minus 8x, minus 9x, plus 12. Split it down the middle. 6 and 8 can both be divided by 2, and they both have an x. 6 divided by 2 is 3x. Negative 8 divided by 2, negative 4. 9 and 12 can both be divided by 3. Bring down the negative sign. Negative 9 divided by negative 3 is positive 3x. Positive 12 divided by negative 3 is negative 4. Do the insides match? Absolutely. Insides, 3x minus 4. Outsides, 2x minus 3. bring down the green highlighted guy. Okay, so let's look at one more problem. These are quick again, don't worry. You remember dots? We've seen it before. Don't forget, dots has no middle term, no B term. We have perfect squares. We use square roots. One's positive and one is negative. The only difference between these dots problems now and the old ones is there are now two numbers to deal with. We have 81 and 25. But again, notice, no middle part, no middle part. Let's see, can we find the square root of 81? We can, it's 9. Can we find the square root of 25? We can, it's 5. That's the first step. Second step is the parentheses. Yes, we get to go straight to parentheses, but it's a little trickier. This first number goes in the first slots. So it's 9x and 9x. As we know up here, we have one positive, one negative. And this second number goes in the second slots. Plus 5, minus 5. We're done. Isn't that nice? Let's look at the second one. 300. What's the square root of 3? Not a nice number. Put that in the calculator. Did you get a decimal? Because I did. So we got to back up. So let's erase everything we just did. This is a dots problem because it is missing the middle part. However, those are not perfect squares. So we need to make them perfect squares. This is where our GCF comes in handy. 3 and 300 can both be divided by 3. 3x squared divided by 3 is x squared. Negative 300 divided by 3 is negative 100. Now, let's take a look. We have a 100 left over. 100 is the only number that we have left. Let's see if that's a perfect square. What's the square root of 100, everybody? Is your calculator giving you a nicer number this time? Should be. It's 10. This is a dots problem. Parentheses. There's only one number this time. So we start with x's. 1 positive, 1 negative, 10 goes in both spots. What am I forgetting? Hopefully you're thinking, you're forgetting the 3. Bring it down. Pause the video. Try the very last example on your own. Start it back up and we'll see how you did. So let's take a look. We have two numbers, 16 and 49. Can we find the square root of them? What's the square root of 16? Hopefully you knew it was 4. What's the square root of 49? Hopefully you knew that was 7. Parentheses. The first number goes in the first slots. 4x, 4x, plus, minus. The second number goes in the second slots. Plus 7, minus 7. That one, pretty easy. Let's look at this one. 20 and 45. Did you try and find the square root of 20? If you did you get a decimal? Yes. So again, we need to back up. Erase everything. Is there a GCF here? Can 20 and 45 both be divided by something? Yes, they can both be divided by 5. 20 divided by 5 is 4x squared. 45 divided by 5 is negative 9. So, he needs to wait. Now we got 4 and 9. Can we square root those? Yes. The square root of 4 is 2. The square root of 9 is 3. Parentheses. First number, first slots. 2x, 2x, 1 positive, 1 negative. Second number, second slots. 3, 3. What am I forgetting? You know it. Bring down that 5. Right, we will see you in class.